Okay, it's page 2 of sophisticated stoichiometry. Sulfur dioxide may be catalytically oxidized, adding oxygen, to form sulfur trioxide. Well, the reaction is sulfur dioxide. Sulfur's from the right, oxygen's from the right. I spy with my little eye, mono, di, tri, tetra. Oh, it sticks and springs and the little ball things. Sulfur trioxide, SO3.
How many grams, blah, 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 blah. We need to balance this thing first. One sulfur, two oxygens plus 2. Now, it's an even-odd situation, isn't it? So I know that I'm always going to have even numbers of O's on this side, because they come in sets of 2. Sets of 2 here, sets of 2 there. So I know I've got to do something over here to give me an even number of O's. So 2 sets of 3, that's 6. Let me see if that works. If I had 2 sets of 3, that'd be 6. 2 sulfurs, I need 2 sulfurs. I have 2 sets of 2 is 4 plus, oh, yep, worked. It's a 2 to 1 to 2 mole ratio.
How many grams of sulfur dioxide would be converted by this process if 100 grams of oxygen is used? 100 grams. Okay, so in this case, in this reaction, I don't have to do anything on this side. Just skip it. But I did need to balance it using this. So if I can calculate the moles here, then I know I have twice as many moles of sulfur dioxide. Should be in good shape. I'll need the grams per mole. Grams per mole. Oxygen, O2, right? There's a 1 in front of it, which I wouldn't use anyway. So 16 plus 16 is 32 grams per mole. 32 grams per mole. Moles equals grams, whoops, 100 divided by 32. Gosh, that's really close to 3, I think. So that means I have a 1 to 2 mole to mole ratio. What's twice as much as 3? 6. 6 moles. The questions asks for how many grams. I need the grams per mole of SO2, which is 30. Sulfur is 32. Oxygen 16. 16 plus 16 is 32. Sulfur is 32, so that's 64. What a weird coincidence. 64 grams per mole. One more time, I hate to say this again and again, but do not use the 2 for calculating molar mass. Don't use the coefficient. All right. Now, let's calculate the grams. Grams equal moles times molar mass. 6 times 64. I bet some of you guys can do it in your heads. 64. Anybody have it yet? 384. 384 grams. It's a combination reaction, also known as synthesis, but I didn't ask you that. What's the answer? Which one of these 6 numbers is the answer? I think I've done enough. You figure it out. All right. Number 7, lightning in the aerobic atmosphere. Hint, hint, hint. Oxygen, aerobic. Catalyzes the conversion of nitrogen to nitric oxide. So nitrogen plus this is going to make nitric oxide, which is NO. N all by itself. Is that ringing a bell? Is that one of Lucky 7? Yes, it is. So put a 2 there. Now, let's balance it. Due to how many grams of nitrogen gas? So that's what I want for an answer. How many grams of nitrogen gas would be required to make 25 grams of nitric oxide? So for some reason, I want to make 25.0 grams, 3 sig figs, of nitric oxide. How many grams of nitrogen is required? Well, let's see, excuse me, it's a 1 to 2 or a 2 to 1 ratio, depending on which direction you're thinking. So we have to figure out the moles here. And we need the molar mass, grams per mole. All right. NO, don't use the 2. 14 plus 16 is 30. 30 grams per mole. 0.0, I need 3 sig figs. Moles equals grams divided by molar mass. 25 divided by 30 is 0.83. 0.83 moles. It's a 2 to 1 mole to mole ratio. 2 is to 1, half as much, as 0.83 is to 1.415 moles. Question, I think, asked for grams. How many grams of nitrogen gas? Well, it's N2. 14 plus 14 is 28 grams per mole. Grams equals moles times molar mass. 0.415. 0.415 times 28. Bingo, 11.6. 11.6 grams. Done! Yeah! 11.6 grams. Put it right there. Game over. Next one. Calcium phosphate, silicon dioxide, and coke. Interesting. An old term. It doesn't mean a drink and it doesn't mean anything bad. Coke just means carbon. It's basically charcoal. And coke may be heated together, so heat them together in an electric furnace to produce. That means arrow, right? Phosphorus. Now, phosphorus is weird. You'd expect it. It's not one of the lucky seven. You'd expect it to just be P. But phosphorus is kind of weird. It makes P4. So sets of 4 phosphoruses. So my apologies. It's not my fault. Blame Mother Nature. Produce phosphorus as shown in the following equation. Okay. Oh, this is going to be a doozy of a problem. Well, it's balanced for you. 2 to 6 to 10 to 6 to 10 to 1. Mole to 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 mole, mole ratio. How many pounds of calcium phosphate? Where the heck is that? Oh, here it is. How many lbs? Hey, that's not grams. Uh-oh. I need to do it in the metric system and then switch it to pounds at the end. 454 grams in a pound. 2.2 pounds is the same as 1,000 grams. You can use that. How many pounds of calcium phosphate would be needed to make 100 pounds of phosphorus? All right. So I want to make 100 lbs. Switch it to grams. Use your molar mass, grams per mole. Calculate the moles. So to get, allow me to do this for you. I'm not doing it for you, just a refresher. 100 pounds, lbs. Save space, equal sign is how many grams? Happy birthday to you is on the top. Get rid of lbs and get grams. Grams is on the top, grams is on the top. 2.2 pounds. 2.2 pounds is the same as 1,000 grams. Pounds cancel with pounds, we're left with grams. 100 times 1,000. 100,000 divided by 2.2. It's a big number of grams. Then you use your grams per mole of P4. Now that's phosphorus is 31, 30.9. So, but it has the 4 here, so make sure you do 31 plus 31 plus 31 plus 31, which is 124, right? 124 grams per mole. The this grams, put it in right there, because we don't want to use pounds for doing this. And then calculate moles. It's a 1 to 2, 1 to 2 mole to mole ratio. Okay, you need the molar mass of Ca3PO4. That's going to be a big one, because I think PO4 is about, I think it might be 96 or something like that. You've got 2 of them. So that's darn near 200, plus 3 calciums, which is 40 plus 40 plus 40. It's going to be something like a little shy of 320 grams per mole. That'll give you grams, and then you got to go from grams to pounds. All right? So you're going to have to think this way, except for you're going to have blah, 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 blah grams, and you want to, some number of grams, I'm going to call it X grams, and you want to get rid of grams and go to lbs, go to pounds. And what were the numbers here? 2.2 pounds is 1,000 grams. This times 2.2, hit enter, divided by 1,000. That should give you pounds. And that's what you want for your answer. Then you got a problem down here. How many grams of calcium silicate? That's this one. How many grams of calcium silicate would be formed as a byproduct as you do this? All right, so basically it's saying how many grams. You don't have to switch this one to lbs. Boy, my are nice. Just go to grams. So it's a 1 to 6 mole to mole ratio here. 1 to 6 mole to mole. Calculate the grams. How much sand? You know which one of these is sand? It's silicon dioxide. Wisconsin's famous for making frac sand, right? SiO2. And how much? Yep, okay, so do that. Oh, there's another question. Carbon monoxide, that's CO. There it is. 10 is the coefficient. Carbon monoxide is gas under these conditions. Using the moles formed in this reaction, remember that 1 mole of any gas takes up 22.4 liters. 22.4 liters. And so you'll have blah, 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 blah. I'm going to call it Y, number of moles of gas. And you want to get liters. Take me to your liters. Get rid of moles, cancel moles, get liters. 1 mole is, how big is a mole box? 22.4. We did this a long time ago. Cancel out. Take your number of moles. That should get you through this beast of a worksheet. Peace out.